Hello and welcome. In this lesson, we'll discuss trigonometric ratios of any angle, and then we'll shift our focus to special angles. So let's get started with some definitions. A unit circle is a circle centered at the origin with a radius of 1 unit. We use the unit circles in trigonometry to better communicate our understanding of trigonometric ratios and as a result, the solutions to many problems that are related to trig ratios. Remember that an angle is considered to be in standard position if the initial arm is fixed on the positive x-axis and the terminal arm rotates around the origin. In our case, the angle of 210 degrees, which is measured when we start from the initial arm to the terminal arm in the counterclockwise direction, is what we call the principal angle. In our case, it measures 210 degrees. Now, any angle, regardless of where the terminal arm is located, will make an acute angle with the x-axis, sometimes with a positive and sometimes with a negative x-axis. In our case, the principal angle of 210 degrees makes an acute angle with a negative x-axis, and in our case, this would be 30 degrees. Remember, this is 180, so out of 210, we're left with 30 degrees here. This is what we call the related acute angle, and it's an important angle to pay attention to because it will help us determine the exact ratios of the angle 210. Remember that on the Cartesian plane, we have 4 quadrants we focus on, quadrants 1, 2, 3, and 4. Now, positive coterminal angles, what are they? Remember that the word co is an acronym for the word common. So, common terminal angle means that angles will share the same terminal arm. A positive coterminal angle is created by going around the circle another rotation or another 360 degrees or another 2 pi. So to build a positive coterminal angle, you simply add 360. We can build as many positive coterminal angles as we wish, so we just have to keep on adding 360. Negative coterminal angles, on the other hand, are created by subtracting 360 or adding a negative 360 degree angle. So a negative coterminal angle in our case will be the angle negative 150. Or you can continue adding another negative 360 and then we hit negative 150 minus negative 360 equals negative 510. And this is what that would look like. Now, let's take a look at primary trig ratios and reciprocal trig ratios. Remember that once angles are placed on the Cartesian plane, we need to place them in standard position in order to analyze them, which means that the initial arm must be on the positive x-axis, terminal arm anywhere around it. Suppose that we are here on the Cartesian plane, and the angle theta is marked by the terminal arm as indicated on the grid with this green line. We measure the angle in the positive direction when we go counterclockwise. We pick a point on the terminal arm, which we usually indicated by letter P, and we'll say that the point P will have coordinates x and y. So if the first coordinate is x, that means if you drop a perpendicular onto the x-axis, then this will be x units long, which makes this length equal to x. If you drop a perpendicular onto the y-axis, then you will know that this will be y units long. So from here to here is y units long, which will be equal to this side of the triangle. So that would be y. So we have a right angle triangle here, as you can see. where we have one side x units and this other side, which is y units. Sorry, make it thicker. Okay. So we are going to say that in this right angle triangle, the sine ratio will be opposite, which equals the value of y, over hypotenuse. So we say y over r. The cosine will be equal to adjacent over hypotenuse, which is x over r. And the tan ratio will be opposite over adjacent, which is y over x. So y over x. Now, regardless of where angle, the terminal arm of an angle is located, so whether it's quadrant 1, 2, 3, or 4, these ratios will always be calculated based on the coordinates x, y, and the value of the hypotenuse, which is r. Remember that r represents the length of the hypotenuse, or the length of the terminal arm. And lengths are measured always, I'm going to indicate terminal arm by TA, and lengths are always measured by positive numbers. According to Pythagorean theorem, we're going to say that r squared equals x squared plus y squared. So if we knew the coordinates of a point on the terminal arm, we can easily evaluate r. Reciprocal ratios are, for sine theta, the reciprocal is called cosecant theta. For cosine theta, the reciprocal is called secant theta. So it feels a little bit of counterintuitive when you think about it, because sine, cosecant, cosine, secant. But that's the way it goes. That's the names that we were given to the reciprocals. And the reciprocal of tan is cotan. To reciprocate a number means to flip the numerator with denominator. Therefore, cosecant theta, since sine is equal to y over r, we'll have r over y. So you just flip them around. Same idea applies to secant. So that would be r over x. So r over x. And for cotan, so tan is y over x, cotan will be the reciprocal x over y. The next thing we want to mention is the cast rule. This is something that you've seen in grade 11, but let's review it one more time in this lesson. Suppose that you have an angle in the first quadrant, and I'm going to draw the angle right here. And we're looking into positive angles. Now, if we pick a point on the terminal arm, then we'll say that this point will have coordinates x and y. And this angle theta, that is marked by the terminal arm OP, will have the ratio of sine equal to y over r, cosine equals x over r, and tan equals y over x. Now, as you can see, since we are in the first quadrant, x will be a positive number and y will also be a positive number. Remember that r is always positive, so we'll say that sine will be positive, cos will be positive, and tan will be positive. Or in other words, we're going to say that all ratios are positive. When we move on to the next quadrant, in quadrant 2, let's pretend that we have an angle that has a terminal arm right in quadrant 2. And let's mark the positive angle. We're going to say that if we pick a point on the terminal arm with coordinates x and y, x will be a negative number and y will be a positive number. What this means is that the sine ratio, this time, would be y over r. And with y being positive, we're going to say that that would be a positive sine value. Cosine is x over r. So x is negative, so that would be a negative number. And tan is y over x, which will be a positive or a negative, which will make a negative. So in this case, the only ratio that stays positive is the sine ratio. So that's why we call this the S quadrant. In a similar way, we reason about the rest of the quadrants. So let's pick another angle now in quadrant 3. So if the angle is in quadrant 3, then the positive angle will be the orange angle that we've marked here. And if we pick a point on the terminal arm, we'll say that the coordinates x and y will be both negative. Now, remember that sine theta, which is y over r, will be negative divided by a positive. Cosine theta will be x over r. So x is negative, while r is always positive, so negative. And tan theta equals y over x. And with y being a negative and x being a negative, we're going to have a positive ratio. So we're going to say that in this quadrant, the only ratio that stays positive is the tan ratio. Last but not least, we'll take a look at an angle with a terminal arm in the last quadrant. So if an angle is in the last quadrant, or the terminal arm is in the last quadrant, if you pick a point on the terminal arm, x and y, you know that x will be positive, y negative. Now we can do this a little bit faster. We know that sine theta is y over r, so that's a negative over a positive, negative. Cos theta will be x over r, so x is positive in quadrant 4, r is always positive, so cos is positive. And tan theta, which is y over x, will be a negative divided by a positive, which will make tan negative. So in this case, we're going to say that the only ratio that stays positive is the cosine ratio. So this is the cosine